So our goal for today is going to be solving equations with complex numbers. So before, every time we solved an equation, take for example this one here, x squared equals 4, we asked ourselves this question, well, what number when squared gives me 4? And there were two possible outcomes. Either x was positive 2 or x was negative 2. Sometimes we wrote that as plus or minus 2. However, historically, if we came across a problem that looked like this, what number times itself gives you a negative 4? We say that's impossible. We can't do that with the numbers we have. And the answer is you're right, we can't. So historically, we've said this, no real solution. No real solution. Because I cannot take the square root of a negative. The caveat is, in the real numbers, I can't take the square root. So, hence the imaginary numbers were invented, and then turns out they were very useful after we invented radar and discovered electrical engineering. All right, so here we go. Let's take a gander at this one. Our goal is to get x by itself, so we do that. I'm going to isolate the x squared by subtracting 49 from both sides. So I isolate the square. Remember, we're doing inverses, so we're going to undo the square. Of course, we know how to do that. I take the square root, so we have to watch out. Every single time you take a square root at this stage, not only after, but now, please put that plus or minus. Because once we take that square root, we're introducing a negative version of it. So we end up with this. X equals plus or minus, what's the square root of 49? Well, that's 7. Now, what's the square root of a negative? It's I. So, take the square root. In this context here, the ideas are exactly the same. We still want to get the square part by itself. We want to isolate the square. Isolate the square. So I'm going to do that in 2 steps. First, I need to get rid of the 32. So I subtract 32 from both sides. Notice you do not have to write minus 32 underneath. If you find that to be helpful, then do it. But most of the time we don't have to, because that's something you learned your first moment in algebra. After this, no need to. So I'm going to isolate the square. I'm going to do that in 2 steps. And the next step is I'm going to divide everything by 2. Again, I'm not going to show me actually dividing by 2. I'm just going to do it. So both these steps are isolating the square. That's the big thing. I did that in 2 steps by subtracting 32 and dividing by 2. Now the next step is to take the square root. I'm not even going to show it. I'm not going to write the radical around it because you already know I'm doing it. Now, if I were to take the square root there, I would get plus or minus 4, but now I also have to deal with this negative, which becomes an I. So I take the square root of both sides. Am I done? Nope, because x is not all by its lonesome yet. So my last step is to add 2. Again, I'm not going to write the add 2. I'm just going to do it. 2 plus or minus 4i. And what step did I do here? I isolate or I solved for x. Isolate the x. Now I'm going to box or circle my answer. All right, same procedure here. I'm going to divide both sides by negative. Don't forget that the inside of the parentheses do not change. When I divide by a negative 2 on both sides, I get negative 36 there, but the parentheses stays pretty much the same. Now I take the square root of both sides, so x plus 1 gives me plus or minus 6i here. And then when I subtract a 1 from both sides, I'm going to write it in what we're calling standard form, such that the complex part, the imaginary part comes second. Here's the real, here's the imaginary. And now we commit to it. going to walk through a quick example on number 4 in case you want to see it. What we can do here is when you do take a square root, oftentimes what you're going to see is this. I take the square root of the negative to get an I. So I is kind of outside here, and then I have a square root of 12 here. And wait a minute, square root of 12 doesn't simplify nicely, but it still does if I were to factor it here, 2 and 6, 2 and 3. Notice that a pair of 2's comes out, and the 3 stays in. So notice how we're going to write this answer. It's not pretty, but I did forget a plus or minus. So it's plus or minus 2i radical, not 12, radical, plus or minus 2i radical 3. Just to see where things came from, the square root of a negative became the I, so that's where the I comes from. When I'm taking the square root of 12, I'm factoring it, and finding any pairs. The pair of a 2 comes out as a 2. Another way to look at it is the square root of 4 times 3, which is 2 radical 3. So the square root of 4 is 2, the square root of 3 stays the square root of 3.